To evaluate an expression such as x cubed minus x plus 1, substitute a given number like x equals 1 in place of all the variables. So I'm going to be careful here to use parentheses, but for this very first one, I'll put negative 1 in place of the first x, so that's negative 1 cubed, minus negative 1 plus 1. So to continue this, we just simplify the expression. So negative 1 cubed is negative 1, minus a minus 1 is plus 1, and we have this other plus 1 at the very end. Minus 1 plus 1 plus 1 is just 1. So that's what it means to evaluate an expression. Take your expression and plug in a number using parentheses where appropriate. Now your expression could be more complicated. Maybe it has 2 or 3 different variables, like this next one here. We're going to evaluate b over a squared plus 1 over a squared plus a plus 1 squared. But for this to work, there's a's and b's, so we have to have numbers for both of those variables. So for this one, let's see, I don't think I have to be as careful with the parentheses because there are no negative numbers. So by that I mean, I'll put 3 in place of the b, then we have 2 squared plus 1 over 2 squared plus 2 plus 1 squared. And the goal is to now just simplify this down to one number. So we have 3 over 2 squared, that's 3/4, plus 1 over 2 squared is 1/4, plus, okay, we have, well, that's going to be 3 squared. Okay, 3/4 and 1/4 is 4/4, or just 1. 3 squared is equal to 9. And so the answer to this part is just 10. So that's the idea. Take some given values, plug them in place of the variables, and simplify your answer. We can use this idea on not just an expression, but something like a formula. Like here I have f is equal to 9/5 c plus 32. This is a formula that converts things in degrees Celsius to degrees Fahrenheit. So for example 1, I want to convert these 3 different values in degrees Celsius into Fahrenheit. And so we're going to use the idea that we did up here, where I'll take, let's say, for example, 25, put that in place of c, simplify the answer, and that should be equal to its corresponding Fahrenheit degree. So starting with 25 degrees Celsius, I'm essentially saying c is equal to 25. Then I refer back to the formula, and wherever I see the letter c, I'll put 25 in place of it. Okay, so now all I need to do is simplify 9/5 of 25 plus 32. So you could write this 25 as a fraction if you'd like. I know 5 goes into itself once and into 25 5 times. So this is really f is equal to 9 times 5 plus 32. So that is 45 plus 32, and that is 77. So to complete this problem, I'll look at, let's say, c is equal to negative 6 degrees Celsius next. So I'm going to take f is equal to 9/5. I'll put negative 6 in place of c and add 32. And at some point, it might be okay just to use a calculator to simplify this value. So I'm going to just multiply 9/5 times negative 6. And I get negative 10.8. And then I'm adding 32 to that. And that is 21.2. So far what we have figured out is 25 degrees Celsius is the same thing as 77 degrees Fahrenheit, and negative 6 degrees Celsius is the same thing as 21.2 degrees Fahrenheit. And I have one last one here, so that is negative 40, so figure that one out as well. Let's see. C is equal to negative 40. I'm going to put that into this formula. And I'm just going to do this calculation right on my calculator. Okay. So that's 9/5 times negative 40 plus 32. And I actually get negative 40. That's kind of interesting. I wasn't really expecting that, but notice that for these two values, the Celsius and Fahrenheit were different, but there's exactly one temperature where the two are the same. Negative 40 degrees Celsius is the same thing as negative 40 degrees Fahrenheit. But the point of this example was your expression could have some meaning. It could be a formula that connects a couple of variables like this one here. For our last example, we're going to use another formula, and that is the area of a trapezoid, which is given by this. The area is equal to 1/2 the height times the quantity x plus y. And down here I've drawn a trapezoid. I'll label what these variables are in my picture. When we talk about the height, we mean that vertical distance, the distance at a right angle from the bottom to the top. So I'm going to call that h. X and y really can be interchangeable, but x represents the length of the bottom, and y I'm going to let represent the length of the top. If you know those three values, you can plug them into this formula, simplify it, and that would tell you the space that this object takes up. Just one really quick thing. The picture I've drawn here is actually an isosceles trapezoid. So that means that those two sides are supposed to be congruent to each other, when really a trapezoid could have one side that looks like this, and maybe another one is quite a bit longer. Whatever the case may be, this formula would always work if you knew the height, the longer side, and the shorter side. And these sides can be also referred to as bases. So let's apply this formula in example 2, where we want to find the area of an isosceles trapezoid with height 4 feet, the longer base is 11 feet, and the shorter base is 5 feet. So what I'm going to do is just write down what h, x, and y represent before plugging them into the formula. So h is going to be 4, in fact 4 feet. X I called the longer side, so I guess that's going to be 11 feet, and y is going to be the shorter base, so that is 5 feet. This time when I plug these numbers into the formula, I'm going to have the units tag along. So area is equal to 1/2. Now the height is 4 feet, so I'm going to put 4 and then feet after it. And then in parentheses, in place of x, I'll put 11 feet, and y is going to be 5 feet, just to see if this changes anything as I go through the process. All right, if I simplify this, area is 1/2. Again, we have 4 feet. Working in these parentheses, because there's two separate terms, I can add those together. Those are like terms. 11 feet and 5 feet, if they are added, is a total of 16 feet. All right, so next would be I have 1/2 times 4 times 16. And actually, it's 4 feet times 16 feet. So the product of those two things is going to be square feet. And that's a good thing. Area, the answer should be square feet if the distance given is just feet in and of itself. So let's get a value for that. The area is 1/2. We have 4 times 16, which is 64. But that is 64 feet times feet, or square feet. Multiplying by 1/2 gives me an answer of 32 square feet. So that is the amount of space that this trapezoid takes up. One final thing you can think about for this question is, we don't have to solve this here, but if you'd like to try it yourself, is what is the perimeter of this object? That is the distance around. Or you could think of adding up all 4 of the sides. So that is like this side plus this side plus this side plus the final side. So I leave that for you to try, but one thing that would be, I think, helpful in solving this is the Pythagorean Theorem, where if you have a right triangle and you have sides A, B, and C, where C is the hypotenuse, a squared plus b squared is equal to c squared. So if you want to give that a try, I say go for it. But otherwise, everything that you need for this lesson is kind of in here, where we're taking formulas, plugging in numbers, and then simplifying those expressions.